Okay, so for the review, um, these problems may not be in the same order yours are on the review sheet, but they're all there. So the first one I've got up here says identify the vertex for the parabola. And the vertex is the point where the parabola changes directions. In this problem, it's down here at the bottom of this red parabola, and it's right there. Okay? And so the point is always, the vertex is always an ordered pair. So the ordered pair for that, remember the ordered pairs are always written as x comma y. So if I start at the origin, I go to the right one, so that's 1, and I don't go up or down, so that's 0. So the vertex for that parabola is the point 1, 0. Second one I've got says solve the system of equations. Okay, and on this one, if you look at those, if I add those two equations together, it's going to eliminate the y, and so we're going to use the process of elimination. The other method is substitution, which can also be done here, but elimination is a lot quicker. So what you do is you just add the two equations together. So you got x plus x, which is 2x. Y plus a negative y is 0, so the y's cancel out. 10 plus 2 is 12. And then to finish solving for x, I divide both sides by 2, and I get x equals 6. Okay. There are two variables, x and y, that we need to solve for. And so what I do now is I take this x equals 6, and I plug that 6 back in for x in that first equation. So I have 6 plus y equals 10. And to solve for y, I just subtract 6 from both sides, and I get y equals 4. So my solution to that system is, once again, it's x comma y, so it's 6 comma 4. And so solving systems of equations, the one that you will have on your test will be a elimination one that you can do just like this one. And for those of y'all wondering, seniors especially, your test will be multiple choice. There will be one that you'll have to graph out or work out, but everything has to be multiple choice, and so maybe that'll help out a little bit. All right. Back to the parabolas. This time, instead of the vertex, we're looking for the axis of symmetry. And y'all, real simple, what we're doing here is the axis of symmetry is the point, is the line that goes through that vertex we talked about earlier. So here's where that vertex was. It's working right. The vertex was at that point 1, 0, and so the axis of symmetry goes through that. That's the line that I just drew up there, is the axis of symmetry. And that is always going to be the equation x equals some number, and whatever this number here is. So in this case, x equals 1. So you're drawing that line that makes everything on the same on the left and the right side of the line. So all of this is exactly the same as all of this. It's just flipped over it. Okay. And so you write the equation for that line, which is x equals, in this case, 1. It will always be x equals some number. Okay. The next one I have is solve the following equation for x. And now this one, you're going to get the variables together. The x's need to be on the same side. And then you work on getting the x by itself. So to get on the same side, the first thing I'm going to do is move this 4x to the left. So since I'm moving it across the equal sign, I got to subtract it because it's a positive. So then I got 6x minus 4x is 2x. Bring down the plus 2.5. The 4x's cancel out. I'm left with negative 1.1. The next step is to get x by itself. So I need to get rid of that plus 2.5. And to do that, I need to subtract 2.5. I got to do that to both sides. So now I have 2x. The 2.5's cancel out. I'm left with, on the right side, negative 1.1 minus 2.5 is negative 3.6. And the last step is to divide both sides by 2. And I get x equals negative 1.8. So I have now solved for x. For those of y'all watching through it, if you get stuck, just hit pause on the video and go back to it. If I move along too fast for you. Okay. On this next one, I don't think it has the directions on there on the review sheet. It will on the quiz or the test. But this one you're just simplifying. And so what you're trying to do is get rid of all parentheses and then combine all your like terms. So over here, get rid of parentheses, combine like terms. Those are pretty much my 2 steps. If there's no denominators, that's definitely what we do there. Okay, and so first thing to do to get rid of parentheses is you need to distribute. So we're going to take that negative 6x and we're going to multiply it by x. So that's negative 6x squared. Okay, sorry about the pause. So we did the negative 6x times x, which is negative 6x squared. And then I multiply the negative 6x times the 2, which is a minus 12. Okay, so that first set of parentheses is now gone. And then I move to the next one. I have the negative x times x is a negative x squared. And then a negative x times 1 is a negative x. And this is the second time I messed up here. Negative 6x times 2 is negative 12x. Sorry about that. So now when I combine like terms, I have those 2 terms to combine. The negative 6x squared and the negative x squared. And then I have the negative 12x and the negative x. So I'll start with the negative 6x squared minus 1x squared is a negative 7x squared. And then the negative 12x minus 1x is a negative 13x. So my solution for this one is negative 7x squared minus 13x. On this next one, what you're doing is you have these 2 matrices, and it wants you to find 7 times matrix A plus 6 times matrix B. Okay? And so a couple things. Remember, in your calculator, you can always hit the alpha button and then the zoom button, and that's going to pull up your matrix stuff. So if you want to plug it into your calculator, you can. I'm going to kind of work this out by hand because it's not real hard. The first thing they want me to do is multiply 7 times everything in matrix A. And so what I end up doing is 7 times 1 is 7. 7 times negative 1 is negative 7. 7 times 0 is 0. 7 times negative 3 is negative 21. 7 times 5 is 35. And 7 times 2 is 14. So what I've done so far is I've multiplied 7 times matrix A. So you take 7 and multiply by everything inside it. Plus, I need to do 6 times matrix B. So we're going to do that same process. We're going to multiply 6 times everything in matrix B. And so 6 times 2 is negative 12. 6 times 1 is 6. 6 times 5 is 30. 6 times 4 is 24. 6 times 0 is 0, and 6 times negative 7 is negative 42. And the last step is to add both the matrices together. And you do that just by adding the individual locations. So in this problem, you take the first row and first column in each matrix, 7 and a negative 12, and I add those together and it goes in the first row and first column in the answer matrix. So that's negative 5. And then I move to the first row, second column is negative 7 plus 6, which is negative 1. Move to the second row, 0 plus 30 is 30. And then negative 21 plus 24 is 3. And the last row, 35 plus 0 is 35. And 14 plus a negative 42 is a negative 28. So that matrix is my solution matrix. Alright, next step, our next part. What is the greatest common factor for this expression? Okay. And on these, you have to find the common factor of the coefficients first. So the largest number that will go into 4, 2, and 6 is just a 2. So that's the first part of my greatest common factor. Then I look at my variables. I have an a squared, and an a. The first two have an a squared in common, but the third one only has one of those a's, and so that's all we can have in our greatest common factor, just one a. And so that's part of it. And then the last variable is c, and we have the same issue with c. We have two of them have c squared, but only one that has a c. So since c squared won't go into the c, we can just have a c there. So my greatest common factor is 2ac. Graph the system of inequalities. So just as a reminder, when you graph a system of inequalities, you have to graph the line and you have to shape. And so on this first one, y is greater than 3x. I'm going to remind you that there is a plus 0 out there, even though it's not written. And that's my y-intercept. So that first inequality, the y-intercept is at 0. So that's right there on the origin. And then my slope, so this one, b is equal to 0. And then m is 3 over 1. So I go from here, I go up 1, 2, 3, and go over 1, and that's where my next point is. Okay, I can also go down 3, and to the left corner, going to go that direction. Okay, and this is not an equal to, it's y is greater than 3x. And so what we have is a dashed line. So try to remember that dashed line for those inequalities. And so there's my graph. Okay. Next piece, it does say that y is greater than 3x, and so that's going to be above. And so in this case, above goes out kind of up to the left. And so there's my shading for that one. Okay. On the next one, y is less than 2. Okay, so this one, there is no slope, so it's going to be a horizontal line. Okay. And then my line is going to go through the x equals 2, or the y equals 2 piece. So go up 2 on the y-axis, it's going to be a horizontal line through there, and it's again going to be a dashed line because it's not equal to. And then my shading this time is down because it's less than. So my solution is everything that is shaded in both, which is all of this out here. So this is my solution. What's out here. All right. two more questions here, quick. Solve for y. To solve for y, I gotta get y by itself. So I'm gonna subtract that 3x from both sides, so I have 2y equals 9 minus 3x. And then I get the y by itself by dividing everything by 2. So y equals 9 halves minus 3 halves x. And I did that one pretty quickly, so pause and look at it if you need to look at it. And then we're good on that one. And then the last one just says it wants you to find the slope of that graph. So slope, y'all, is rise over run. And so I just need to find a couple of points. Any of these spots would work, because that's where that red line crosses the vertical and horizontal lines. So if I start at one of them, my rise as I go down 2, that's negative 2, and then I go over 1, 2, 3 to the right. So it's negative 2/3, and there's my slope. And that is all the problems. So if you have any questions, you can email me, message me, let me know. Thanks.